Welcome to 16 Bits channel, and the topic for today is numbers part 2. In the first part of this number, I talk about of primitives, and today I bring to you big decimal, big integer, long, double, and float. And the third party, let's say here, yes, on the third party, after the second video, I bring the numbers of atomic package. Okay, so just to recap the video and the target and the goal. On the first video, I bring the primitives, and this second video, I bring to you the big decimal, the big integer, long, float, and double. And the next video, I'll bring the class of the package atomic concurrency, in fact, because the class are atomic integer, atomic long adder, long accumulator, yes, double adder, double accumulator. Okay, so that's it. Let's see how to work using this number in Java. And remember, each project and each system has your requirements, your way to handle the data, and just pay attention when you decide use integer instead of long, or long instead a big integer, because today the system is handling few data, but in the near future can handle a million of data and a million of rows, and this could be a bottleneck, or worst, should be a bug. Okay, so that's it, and let's go to the code and see how to decide and see the capacity, and also make some tests to fixing and to see the idea. Okay, so let's go. Thank you for having me here again, and let's go. Okay, firstly, as I said before, today I bring to you some code, okay, regarding numbers, and the numbers I'm using my GitHub project. Okay, so let's move this customized number to another class, just numbers. All right, just to move, yes, that's so good. Okay, so now I'm extending abstract class number, in this case customized number. This is number just to play on my environment. So the basic idea is bring to you big decimal, big integer, double, float, integer, and long. Okay, so that's the idea for today. So let's go to the test class. Right now don't have test class for this one, that's weird, but no problem. Okay, let's move this package to correct package, and okay, let's move to the package correctly, and okay, that's good. Numbers, and I have customized number. Okay, that's good. So in order to make this easy, let's start with integer, because just to see the capacity. Okay, so that's assert that, in this case expected, as in this case my expected value is equals to, in this case let's put the integer ponto max value. Okay, just to play with this test. max value and create this expected one. We can use a primitive just to start off. This is try along, but I want to use along. Let's put this one here, integer onto max value. Okay, so this I'm trying equal to. I'm trying to compare two values, and I said on previous video the integer has the same capacity of the integer. The main difference is the integer class has more methods to handle, in this case with numbers. Let's say I had a string. I want to convert this string to number. Is you have to parse on integer class to do this kind of work. Okay, so let's switch the test run. Let's try to run. Let's put this for another. Yes, that's good. Okay, just to see my face shorten and running. Let's running. Okay, play with integer. In this project I'm using Allure for reports, and all the time is the Allure log. But okay, it's fun, it's working. So let's just change the name. Let's play display name as integer, and also you can try to do another asset. I don't create a lot of tests to explain, because the idea is very direct to the point. Okay, so in this case let's create a string, put the magic number. Let's say you have the number 2021, and then the integer you can use a parse int in this case, and use again this magic number, or let's say integer dot compare. I don't want to compare value of, use the magic number. Okay, the difference between these two methods in this case is one method is calling another method. In this case, the value of, like, this is better use the another one. In this case, parseInt is calling the parseInt, and the parseInt for your instance is calling, let's say, oh, this is a lot of count. Oh, this is formatting. Okay, no problem. It's formatting. Okay, that's good. Let's see. Result is ignored. Okay, no problem. Let's put a variable here and parse int. In this case, you can introduce a variable calling magic number. Okay, now converted. Now we have here the main difference. In this case, the value of return you object, the class, and the parse returns primitive. This is the main difference between them. Okay, so if you understand this main concept of the integer, you can play with int and play with the class, and using class to take advantage of this kind of method. In this case, let's say decode, divide, and get the integer, or maybe parsing a number, because if you have this one another variable and put this one magic number, it's impossible to convert. Even you do that, this is impossible too. Okay, it's not allowed in Java transform a string and convert to making cast to int, a primitive int. So because this, you need to use the class and use the static methods to transform a value in a string. Even though if you use the new, it's a bad idea because the constructor, I remember, is deprecated. You know, if you see this kind of code or notation in your code, you need to avoid, because mira, or see, deprecated since Java 9. Okay, so you need to jump to use another approach using parseInt if you want to use a primitive, or using a value of if you are using a class. Okay, if you want it, you can assert these two values. Okay, assert that, let's say assert that magic number converted, let's copy 122 string is equal to magic number. You can do some assertions here, or even use the parseInt to do that. Let's do this also. Assert that parseInt is equal to the magic number converted dot int value. Okay, you are comparing some values. In this case, this is valid for integer and long. The main difference between you have the integer in use along is, as I said on the previous video, the capacity of them. Okay, so in using a long value, you have the double of capacity. Is a win-win when you need to store more data and so on. Even if you want to store more than you need, or I mean twice the long max capacity, you can jump this long because it's the same. The point is just to, let's copy and paste just to see. It's just to use, instead of using the integer, you can use the long. Instead of use integer, you can use the long. Okay, you can just to change this is don't make sense pass to this number again, because it's all the same. Also the same method is the same name. In this case, you have the parse long. In here you have the long and value of, and change it to long, and change it to the class long. Okay, so this is the let's change the name, parse long, and instead of call int value, you can call the long value. This is the same. Okay, don't have to be concerned about that. The only thing you need to pay attention is the max value of the long. Okay, and this is okay. For double, we have the double and the float, the same approach as I said before. If you need more capacity, you can use one instead other, and also to declare the declaration, let's say double my double, set double value of, let's say, a 9999 G. This is a double. This is the, I can extract this to a variable or not, and assert that, in this case, that my double dot, my double float value, in this case I'm comparing with float, okay, is equal to, let's create a new float, and my float. In this case we have some kind of issue because in terms of conversion, okay, but it's not the topic right now, just to to show how the numbers works. I know I'm not go deeper in this topic because the main point here is talk about the capacity, and you can play in your computer or using Katacoda in your, let's say, about numbers, about everything regarding this number, integer, long, and so on. Okay, for terms of, let's say, you want to compare things, you want to, oh, that's okay, that really well. Well, about the float, the good practice said you don't have to compare the float numbers because float has another kind of behavior. Okay, so now we can just to use int value in this case, and you can use this one here as I reset on the bubble is using the parse. Instead, let's use the value of instead to use of this is of string point value of this is okay. Just use this kind of situation to compare float. I don't like to use that, okay, because it's a lot of conversion to compare one thing. It's not a good idea, but sometimes you need to compare, so maybe is a good way to convert to int, or let's say you want to convert to long. Isn't it possible? Okay, oh no, impossible, sorry, it's possible, and then you convert to long and try one to need. In this case, I aware this number is acceptable to int value, so let's maintain this float working with this kind of test. Okay, so okay, now it's time to use the big integer. The big integer, as I said before, is for big numbers. Okay, if you have in this case I'm doing in fact a repetition for 3. No, oh, sorry, my fault. Okay, my bad. A number from, okay, no problem. This is should be, for now I put here disable. Okay, yes, just put a disable here. After I will fix this kind of test because using this is a little bit weird. Okay, so back to integer, and then here I'm getting the max value of a long, and after I will put this inside a big number. Okay, big integer. If I had, instead of 3, I had 13, I have 50, 100, no problem. The big integer is able to store everything you need. Okay, so let's try to 3, and then assert that. In this case, I want to use this one, big integer, multiply for 3, and let's say this is the multiply is okay. Okay, so I want to check if my multiply is equal to the reduced variable. Multiply is equal to reduce. Okay, this is the single way. Multiply provide here. Okay, big, in this case I need to use a big decimal value of 3. You don't like this? Let's say no, they don't like this one. Okay, now they like. Okay, so I want to just to, oh, again, what happened? Oh, sorry, my fault again. Big integer. I put big decimal. So big decimal, I don't want to put that because just 3 is okay. So I want to multiply a big number 3 times. I want to see if they are equals, okay? This is another way to create a for if you want, or if you want to use a for instead of int string and map and reduce, is up to you. I put this one here just to play, just to, okay, I thought, okay, let's put something different instead using the for index and so on. Okay, this is the general idea, and see what happened. As I'm doing here using the big integer, is apply also to big decimal. The main difference between big integer and big decimal is big integer is just for number without precision or decimal precision. If you use big decimal, you see here, multiply for 3, I have this number. Okay, no problem. If you want to, let's say, formatting with precision and rounding the decimal, round something inside the number, you need to prefer big decimal or make some calculations big decimal instead of big integer. Okay, otherwise, for numbers or just for IDs, prefer big integer instead of big numbers, big decimal. This is another big decimal, big integer. Well, let's, oh, no problem. This is a test. I'm doing this one. No, let's we can do that better because this is need to be let's say avoid and copy and paste, but just to don't spend more time explain, it's better use paste in this case. So let's exchange big integer for big decimal. Okay, in everything gonna be the same. Now I have the big decimal, unhinged and close, mapping this one, and want to transform, and then you want to add. And after I want to multiply the big integer here to big decimal. And then, okay, now I want to change this number to decimal or max long value. In this case, is true because this is a max long value, okay? And, sorry, max max long value. I want to multiply for 3 and then see if the two are okay, are the same. But as I said before, you want, let's say, use some precision in the number. You can use set scale in this case, let's say for 3 houses, and put here the math. Let's see, yes, rounding mode, okay? If you're sailing down floor, half, and so forth, okay? Just up to you. Just to remember, big numbers use the big decimal or big integer. And if the big number, let's say, is applied just, let's say, for ID and for calculation, it's fine, it's good. But if you have in your system concurrency, it's let's say, pay attention because you want to choose or to pick another kind of number. But this I will introduce in another video, just to see the stats passing and see what happened. This is the same. I need to refactoring this test, but for now it's okay, it's funny. because you're using the transforming the long max value instead of using a big decimal and then add this value. Okay, so for this video I want to, in fact, I'd like to show this one, the kind of number, the capacity of number, and how to change or how they are interchangeable, how you can play with each other. Okay, if you want to choose a long or an integer and so on. The main difference, let's say, if you're using a long and after change to integer, is changing also the method, the association of this field, and so on. And the big integer is the same, and the headache to changing your system in all the system. This is the headache you had when you, let's say, modeling a system and need to change a kind of field. But it's normal, it's the real life. This happen in the system is alive all the time. Okay, so that's it. Thank you for your attention and see you on the next video. Bye bye.